Karibu, welcome. I want to welcome you to this lesson. We are going to calculate some titration question here. So tunaenda kuangalia hili swali kwa mwendo wa polepole ili tupate kuelewa ni nini tunafanya. So let us try to read together this question. You are provided with hydrochloric acid labeled solution A, solution B containing 6.4 grams per liter of sodium hydroxide. This information is very crucial for us to understand. Inamaanisha kwamba solution B was prepared by dissolving 6.4 grams to form 1 liter of the solution. So first what you do, you write that 6.4 is the grams per liter. Very important. We need that and we will use that. So that is the grams per liter. What are you going to do? You are required to prepare a dilute solution of hydrochloric acid. So we are required to dilute this solution. Then finally, determine the concentration of dilute hydrochloric acid prepared and the concentration of the original hydrochloric acid solution A. Very good. So procedure. Na ni vema sana kuelewa procedure because you just follow instructions. Na kuelewa procedure pia is very important for you to calculate this question without making errors. Procedure 1. Using a 50 ml measuring cylinder, measure 25 centimeters cube of a solution A. Remember, solution A is hydrochloric acid. So solution A is hydrochloric acid. Transfer it into a 250 centimeters cube volumetric flask. I hope you know a volumetric flask. Fill the solution transferred into the flask to the mark with distilled water. So hapo unafaa kuelewa kwamba kitu ya kwanza tumetransfer 25 of solution A. Solution A ni HCl. Tumeweka kwa volumetric flask ambayo ni 250 centimeters cube. Tumefanya nini? Tumeongeza distilled water ikafika 250. So kitu ya kwanza unafaa kuelewa hapa ni kwamba hii solution original A ambayo ni HCl ilikuwa na moles fulani. 25 iko na moles fulani ambazo hatujui. Lakini kitu ni kwamba number of moles yenye iko kwa 25 hapa will be equal to number of moles of solution C ambayo ni HCl diluted 250. Did you hear that? Nimesema hivi. Tukisha dilute tumepata solution C. Lakini solution C ni nini? Ni HCl. Sawa? What is the difference between A and C? C, the concentration is lower. It is diluted. This one, the concentration is high. Umesikia tofauti? Aya, 25 moles hapa, 25 centimeters cube hapa hii ndio tumeweka kwa 250 volumetric flask, tukaongeza maji ikafika volume, total volume ikakuwa 250. So hiyo inamaanisha nini? Inamaanisha kwamba the number of moles in 250 is exactly equal to the number of moles in 25 of the original. Let me repeat that. Kwamba moles, ukicalculate the number of moles in 250 ukipata moles in 250 of solution C, utakuwa umepata moles in 25 centimeters cube of solution A, the original. Moles ya 25 of the A, original solution HCl, is exactly equal to the number of moles of 250 centimeters cube solution C, ambayo ni HCl but diluted. Thank you. I hope you have understood that. So let us go to procedure 2. Fill the puree with solution C. Now we have prepared solution C, remember. Solution C is HCl. The difference is with A is that this one is diluted. This one is high concentration, low concentration, but ni nini? Ni HCl. Fill the purette with solution C using a pipette and a pipette filler. Place 25 centimeters cube of solution B into a conical flask. Add 2 drops of phenolphthalein indicator and titrate with solution C. Record the result in the table below. So let us assuming you have done this practical, so I will give you the values. Here we will have 19.0. I want to use 1 decimal place. Remember, the decimal place has 1 mark and it should be consistent. If you have decided to use 1 decimal place, use it to the other. So I'm going to give you the initial here is 0.0. And then here you subtract, we will get 19.0. The second column, we will have 18.9. I will give you initial to be 0.0. And then the final volume is 18.9. And then I will give you here 19.2. Initial will be 0.0. And then here we will have 19.2. Right, so let us go down and see the questions. Determine the average volume of the solution. So I have assumed that you know, you have learned about this table. For those who don't know, make sure that the table is full complete. If the table is fully completed, like it's fully filled with numbers, you will get 1 mark. If you have maintained the decimal place either 2 or 1, like I have maintained here, you have another 1 mark. If your subtraction, like 19 minus 0 is 19.2, like this is called arithmetic. So if it is correct, you have another mark. So these are 3 marks that you should ensure that you score. The next thing we want to look at now, determine the average volume of the solution C used. Always remember solution C is HCl. Like in this HCl, the difference with A is that this one is highly concentrated, this one is diluted. So determine the average volume. Average, we calculated the average. So that is 19.0 plus 18.9 plus 19.2 and then divided by 3, which will give us 19.03. Let us give it to 2 decimal places here, the average. That is our average volume. Next, determine the molarity of sodium hydroxide solution B. Determine the molarity of sodium hydroxide solution B. Sodium is equal to 23, oxygen is equal to 16, hydrogen is equal to 1. We have 2 marks there. Now, it is very important to remember this. Solution B, how was it prepared? By 6.4 grams formed 1 liter of the solution B. So this is the mass in grams per liter. So I am going to give you a formula here, which is very essential, very important. I want to give you this triangle here. Ambayo tunasema molarity mass in grams per liter RFM. I know you know what RFM is. RFM is molar mass actually. RFM is molar mass. So we are asked to calculate molarity. So from here, how do you get molarity? Molarity is equal to mass in grams per liter. What we have here. Grams per liter. Ndio hii. Mass in grams per liter. Very good. So mass in grams, molarity is equal to mass in grams per liter over FM. So we write that formula that molarity equal to mass in grams per liter divided by RFM. But we have the mass in grams per liter is 6.4. We have RFM of sodium hydroxide. Sodium hydroxide is written like this, which is equal to 23 plus 16 plus 1, which is equal to 40. So the the RFM molar mass of sodium hydroxide is 40. Now, which gives you 0.16 more capital M. Capital M stands for molarity. Very good. Let us go to question Roman 3. We are using this question. Determine the moles of sodium hydroxide in 25 centimeters cube of solution B. Determine the number of moles of sodium hydroxide in 25 centimeters cube of solution B. So it is simple. We have what is molarity? You remember, molarity is the number of moles in 1 liter in 1,000. So we are going to ask, if this is the number of moles in 1 liter, what about 25? So you say 0.16 is the number of moles. This is molarity is the number of moles in 1,000 centimeters cube of solution B. So what about 25 centimeters cube? What will it be? So this times this divided by this. 25 times 0.16 divided by 1,000, which will give you 0.04 moles. Lakini ukiona hiyo ni ngumu, wacha nikupe formula. I want to give you another triangle. Moles is equal to molarity over volume in liters. Volume in liters. So let me use this formula here. Determine the number of moles of sodium hydroxide in 25. So my volume is in 25, but not in liters. Molarity niko nayo, solution hii ilikuwa hii, and then moles ndio natafuta. So moles equal to molarity times volume, and this volume must be in liters. So molarity is 0.16, volume in liters, volume is 25 divided by 1,000, which makes it to a liter, and this one gives you 0.04 moles. Okay, sawa hapo. Thank you. So I've given you already two types of. If you want volume, you will use this. If you want molarity, you have moles and volume, you get this. Thank you. Let us go to the next question. Next question says that write a chemical equation for the reaction between sodium hydroxide and HCl. So sodium hydroxide is simple. Sodium hydroxide plus HCl, which will give us sodium chloride plus water. This one is a liquid, this one is aqueous, aqueous. So all of them is aqueous. Okay, now next one, let us look at this question. Calculate the number of moles of solution C that reacted with 25 centimeters cube of solution of sodium hydroxide, solution B. This one is simple because from here, solution B, we already know the number of moles. Remember the ratio, the mole ratio is 1:1. Remember, moles of sodium hydroxide tunajua 25 centimeters yenye react, this one is 25 centimeters cube. Sodium hydroxide reacted with 19 centimeters cube of HCl, solution C. So number of moles of sodium hydroxide we know is 0.04. Therefore, since the ratio is 1:1, number of moles of sodium hydroxide is equal to the number of moles of HCl, solution C, that was used, right? So let us go back to our question. So we say that since mole ratio is 1:1, moles of HCl solution C is equal to 0.04 moles. The ratio is 1:1. So let us go ahead and calculate part of Roman 6, Roman 6. Determine the molarity of solution C. First, I want to define for you what molarity is. To remind you maybe, molarity, this is what you should know, is the number of moles in 1000 centimeters cube of a solution, of a given solution. Molarity is the number of moles in 1 liter, 1000 centimeters cube of a solution, whichever solution you are given. Now this one, solution C, remember solution C tulitumia 19. That's why you need to understand. Average volume of C used 19. So solution C yenye tulitumia ni 19, yenye react ikafika neutralization na sodium hydroxide. So 19.03 centimeters cube moles zake ni hizi, kwa sababu hii ndio react na sodium hydroxide. Moles yake ni 0.04. So the question is, what will be the number of moles in 1 liter? Because ndio inaitwa molarity, 1000 centimeters cube will be what? So 1000 times 0.04 divided by 19.03, which will give you 0.21 molar. Capital M stands for molarity. You can also write 0.21 moles per liter. Hii na hii ni same. Lastly, determine the concentration of the original hydrochloric acid solution A. Determine the concentration of the original hydrochloric acid solution A. It's very important to remember this, that solution A, 25 centimeter cube of solution A is the one that made 250 centimeters cube of solution C. Na nikasema the number of moles in 250 solution C will be exactly equal to the number of moles in 25 centimeters cube solution A. So having that in mind, so I know the number of moles of solution C in 1000, or I know in 19, so I can use whichever. So I can say 19.03 centimeters cube of solution C equal na 0.04 moles. That one I know for sure. Now I will ask, what will be 250 centimeters cube of solution C half? I want that. So 250 times 0.04 divided by 19.03 will give me 0.05255 moles. So this is the number of moles in 250 centimeters cube solution C. Don't forget, number of moles in 250 solution C. Remember, moles in 250 solution C will be exactly equal to the number of moles in 25 original, because moles does not change when you dilute. What changes is concentration. So remember now, meaning that moles in 250 centimeters cube solution C equal to moles in 25 centimeters cube solution A. Sawa? Now the question is asking me to determine the concentration of the original, so the concentration, right? Which is simple. The concentration. Now I know that 25 centimeters cube iko na hii moles 0.05255 moles. That is now solution A. That's this. So what will it be? 1 liter half, 1,000, 1 liter half, 1,000 centimeters cube of solution A will have what? So that is 1,000 times 0.5, 0.5255 divided by 1,000, which will be equal to, which will give us 2.1 capital M. So this is the concentration of solution A, the original HCl. Thank you. Subscribe, share, do what you. Thank you.